So hello everyone, in the last class we are seeing the properties of the conductor. Now we are going to continue that thing. Okay, so let us just start. So we have seen the two properties. Now let's move to the third property. What is the third property of the conductor? Third property of the conductor is state that suppose I have a some conductor. Okay, I'm taking the general case, not a basically no, any case. I'm just taking a general case. Let's take some general shape. Okay, wait a minute. Yeah. Let us take a general shape. It is a some conductor. Okay? It is a some conductor is there. The material is filled there. Okay, there is a material, or it is better to give me one. Okay, let us suppose some solid. This is a some conductor. Okay, some conductor. Correct. Suppose this is my conductor, and as we have seen that E inside is equal to 0. So I can say my Q in, so Q inside will be also equal to 0 always. That thing we know, but just it is a property, so we will note it down. Correct. Next point. Next point is suppose this is a my conductor. Correct. Some conductor shape is there. Okay. You will understand why I have drawn like this. Suppose this is my some conductor like this given. Suppose I given a charge Q. Now my question is that whether the distribution will be uniform or it is non-uniform. Where the distribution will be uniform, where the distribution will be non, whether the distribution will be, or if the charge will, first the distribution is uniform or non-uniform. It is uniform or non-uniform. It is a non-uniform because why? Because the shape is not regular. First thing. Okay. Second thing, where the charge will distribute more. So remember that the charge distributed is inversely proportional to the radius of curvature. Okay, radius of curvature. So I can say from here the radius of curvature, here the charge distributed, here the radius of curvature will be more, so here less, so here the charge distributed will be more, here there will be more charge density, means here the sigma 1 is here, and whatever the charge density here, because the radius of curvature is more, the charge distribution will be less, so here the charge distributed will be, in this case the large surface charge density is sigma 2, so sigma 1 will be more than sigma 2. That is the second thing. Sigma is the local charge density, remember that. Sigma, if we are saying sigma is basically a local charge density, okay, at a small point. Clear? So it is inversely proportional to the radius of curvature. More is the radius of curvature, less will be the charge density, and less is the radius of curvature, more will be the charge density. Clear at this point? Okay, so let's move to the next point. So if I ask you, so that is why you will understand one thing, that whenever if you have seen some teacher, they will say that, yeah, suppose this is my sphere and I am giving a capital charge Q here. So you will find that they will say the charge will be uniformly distributed. Why the charge is uniformly distributed? What is the reason? Because the radius of curvature at every point is r only, it is same, so the charge will distribute uniformly. That is why here charge distribution is uniform. Okay, charge will distribute uniformly. Correct? Charge will, now I think every concept will be clear, or you are getting the reason for everything. Charge will distributed uniformly here. Why? Now you understand, I think so. Distribute uniformly here. correct? Any doubt here? Note it down fast. Clear? Completed? Okay. Let me see any properties left. Let me check. One more thing. It's not a property, but just for my sake, I am telling you this thing. Suppose there is a some charge outside is also there, and there is a some charge, or you can say there is a some electric field is E external is also there, okay, and there is a small charge is also there, and obviously there will be charge induced, correct? That you know. So here also, if I find the E internal, it will be what? It will be 0, and it will be 0 due to whom? Due to E due to Q plus E due to external and plus E due to induce, correct? This whole due to the sum of all this thing will be equal to 0, correct? So my E net is 0, inside my net electric field is 0. It doesn't mean that the electric field due to this Q is 0 or E external is 0 or this thing is 0. It doesn't mean. Clear? So just clear with the everything what at every point. So these are the important points regarding the electric fields. I hope everything is clear for you now. So these are the very important properties of a electric field, or sorry, conductors. Now we will move to the one small derivation, that is a very small derivation, that is a electric field just outside the conductor, just outside, okay? Electric field just outside the conductor. I want to calculate the electric field just outside the conductor. Okay, so let us see. There is a one conductor is there, correct? And I am talking about just outside the conductor. Okay, suppose I have given the charge Q here. The charge will distribute. Okay, it is distributed like this. Suppose the charge is distributed. I want to calculate the electric field just outside, means it is just outside. So what I will do, I will just draw the Gaussian surface, correct? So let me draw the Gaussian surface here. Okay, I have drawn the Gaussian surface here, correct? Any doubt here? Suppose here the surface charge density is sigma, that is coulomb per meter square. E dot dA vector is equal to, that is Q in by epsilon naught. Now E dot dA, that means electric field dot dA vector. At this point, what is the direction of electric field? Obviously the electric field will be like this, correct? Any doubt? Okay, so I can say there will be two surface will be there, curved surface and flat surface. Now you know all these things. For this the E dot dA will be 0, only with this surface we will get, correct? So what is the value we will get? We will get how much? Tell me, how much we will get? For this curved surface, E dot dA will be again 0. Why? Why here? Because the internal electric field is 0 na. Array, it is inside point na. Here the E internal is 0. So for this surface again E dot dA, only one surface we will get. That is for one surface it is again 0. First surface. For this surface we will get only one case. So we can write E into A. Area is A. What is Q in? That is sigma into A, correct? By epsilon naught. So what is the electric field just outside? So just outside the conductor, the electric field will be sigma by epsilon naught. Means suppose this is my conductor, suppose just 0.00001 mm distance. What is the electric field? That is sigma by epsilon naught, correct? Clear? So this is the electric field due to the just outside the conductor, just outside. Clear? Okay, that is sigma by epsilon naught. Now the next thing I want to calculate, is what is the electrostatic force, sorry, electrostatic pressure, not force. I want to calculate the electrostatic pressure. What is the electrostatic pressure here? Okay, electrostatic pressure. So let us see the electrostatic pressure. So basically what is suppose At this small point, let me draw this same thing here. uh, थोड़ा हम बना लेंगे फिर। Suppose this is my conductor. Clear? Let me draw it proper. Suppose this is a conductor. I have given a positive charge. Correct? Correct? Any doubt here? Till here, anyone have a doubt? Okay. And I want to calculate the electrostatic pressure at this point. Suppose at this point it has a charge dq. Correct? So what is a force? That is equal to obviously sigma into dA. So what is force? Small force on that dq. Force on dq. That is how much? What is the force on that dq? Can you tell me? That is force will be equal to, force is how much? Q into E, correct or not? So what is Q? That is sigma dA. And what is electric field? Sigma by epsilon naught. Answer is wrong. Because when we are calculating the force, we are writing the electric field due to the other charge, not by the itself. So you have to find the electric field by the rest of these charges, rest of this surface. Correct? So what is the electric field will be here? Here, what will be the electric field? See, that sigma by epsilon naught is a total electric field, and this is due to this small point, due to this thing, correct or not? See, this is the electric field, we know that is sigma by epsilon naught. True. And at this point, if it is just outside point, just outside, what I am trying to say, this is electric field, there will be two, the electric field due to dq and the electric field due to the other. Correct. This other part, this is the other part. Now see, we are talking about electric field due to dq. This is charge is just outside, and I can treat it as an infinite plate, basically infinite thin sheet, infinite positively charged sheet. What is the electric field due to the infinite positively charged sheet? That is sigma by 2 epsilon naught. So this value will be sigma by 2 epsilon naught minus sigma by epsilon naught. So what is the electric field due to the other? That is sigma by 2 epsilon naught. So this will be here sigma by 2 epsilon naught. So from here you will get force per unit dA, that is sigma square by 2 epsilon naught. So our electrostatic pressure, correct, that is equal to sigma square by 2 epsilon naught. That is a very clear thing you have to remember. That is a total electrostatic pressure will be defined as sigma square by 2 epsilon naught. I hope till it is clear. This thing maybe you are not comfortable with this thing, but it is true. Why? Because see, we have told that if suppose this is my palm, okay, and there is a small distance I am taking here. So for if you compare this distance with the length of this palm, it will be very small. So for this, for suppose there is a one insect is there, suppose ant is there. For the ant, this hand is like a infinite thing now. For that ant, this is an infinite thing. Similarly for here also, if I am taking just outside point here, so for that dq charge, this thing will be look like an infinite plate. That is what I am trying to say, and that is why I have written this as a sigma by 2 epsilon naught. I hope now it is clear for you. Just take a note of it. If you have any doubt, please ask me. Done? Okay. So this is how we have defined the properties of conductor, and we have seen the different things regarding the conductor. I hope till here everything is clear and there is no doubt is left. Now our next thing we are going to see is the very important topic that I told you that it is completely for the JEE advanced student and the JEE student and the NEET student also. It is important, but after that whatever the session is going to happen, that is only for the JEE advanced student. This session is important, but after that whatever the session I am going to take, it is only for the JEE advanced student, correct? So just for those students, they can attend this session. So let us start. We are going to discuss about the conductors. Sir, here also conductor, there also conductor. Yeah. Here basically we will divide our conductor into three. Basically we are going to divide our conductor into the two types. In here what we are going to discuss, we are going to divide them into two types. One is hollow conductor. One is hollow conductor and one is solid conductor. Okay. In hollow conductor, we have two cases. One is inside and one is outside. Similarly, in solid conductor, we have two cases. One is inside and one is outside. Clear? If you see, in this case, let me draw for you. Okay. See, these all are conductors. In this case, this is the hollow, means there is no material inside. So whatever the, and as it is a conductor, so whatever the charge I am going to give, all charge will be present on the surface, correct or not? And it will be uniformly distributed also due to the radius of curvature is same everywhere. Are you okay with this? Similarly here also, so there will be no charge. It is sure that the electric field inside will be zero and there will be potential, Q in will be also zero and potential will be constant. This is sure inside here also. Here it is sure. Are you okay with this or not? Similarly here also, if I am going to give the charge, here also the charge will be present at where? It will be present only on the surface, outside point, because as we are going to discuss here, the outside point, I can say one thing that is sure, that is V is constant, E in is 0 and Q in is also 0. That is sure for this. Similarly for the solid case, if it is inside, means there is a material inside is there, means inside there is a material. There is a material inside, that is sure. Some material is there. But what is the important point? There is a material, but what is the important point? If as it is a conductor, so whatever the charge we are going to give, okay. So whatever the charge we are going to give, this charge will be present at the outside only. It is a conductor, but whatever the charge we will give, it will present only on the outside. So here also we can say my E internal is equal to 0, my V is equal to constant, correct? And similarly my Q in is equal to 0. Similarly here also, if I give the charge, I can say here also the charge will be where it will be present. Again it will be present on the outer surface and my E in will be 0 and my V is equal to constant and my Q in will be 0. Means what we understand from here, if it is a conductor and whether it is hollow or solid, it doesn't matter. Okay, it doesn't matter for them. Okay, whatever the property for this, the same property for this, same property for this, or same property, means whatever the formulas we are going to derive for this, the same formula we are going to see for everywhere. Whatever the formula for this, the same formula is applicable here also, same formula here also, same formula here also. Okay, so what is the thing we got? We got to understand that if it is a conductor, whether it is hollow or solid, it doesn't matter, it will be, everything will be same. So they all having a same property, means same formulas. So same formulas for them, formulas for them inside and outside both. Okay, for them it is going to be same formulas. That is clear? Any doubt here? If you have any doubt, please tell me. Clear? Okay. Similarly, just I am going to conclude only. I am going to just, similarly we have a non-conductors also. Non-conductors. In non-conductors, again we have a two cases. One is hollow and another one is solid. And again we will come a two pictures. One is inside, same as it, like that only, and one is outside, as we have discussed earlier. Here also we will have a two pictures. One is inside, correct, and one is outside. Any doubt here? No doubt. Okay, if it is like this, then I will ask you the another thing. Correct? For a hollow case, if there is no material and it is a hollow, then obviously the charge will be here only. Are you getting my point or not? It is sure the charge will be here only. Correct? Similarly, if the charge is here, I can say my E in will be 0. Similarly, my Q in, as Q in is also 0. What is the potential? About potential you can say. What will be the potential? If internal electric field is 0, then obviously my potential will be constant. Correct? Similarly, here also it is outside we are talking about, but we can't comment about outside right now. But yeah, we can say one thing, that is E internal here again 0, Q in is again 0, and V is constant. Similarly, for solid we have inside and outside. Yeah, here there is a material is there, so charge will be present inside also. Now here the properties are different. Now here we can't comment about, we have to derive each and everything now, because here in this case my E internal is not equal to 0, because my Q in not equal to 0, and also my V is not equal to constant. Okay, so you can see here from here, that is this are same as conductors. They are same as conductors. So if you see, our whole study is divided into two parts. One part in which we have to discuss 1, 2, 3, 4, 5, 6 cases, just one case, just 6 cases are converted into a one case, and that one case we will discuss and we will remember all the formulas. Similarly, here also we have to discuss two cases for here. So we have combined everything. We have concluded that we have to discuss only two cases. One is this case, conductor case. We can discuss any one of the case, that will be the same formula, and then we have to go for discussion of separately for this case. So that is our conclusion. So we have to discuss about only two cases, and we have to remember only the formula for this case and then this case. And so our number of formulas will be reduced, and they are the very important part. We will, in the next session, we will do the derivation regarding it, because the derivation is also important, because they can give you the variable charge density and then they will ask you to do the derivation for this same thing. This type of question are asked in the previous year. If you go and check, there are a lot of questions are there only for JEE and the advanced point of view, and for NEET they have directly asked the formula. So for the NEET student, they can see the formula derivation and they can remember all the formulas properly. In the next coming session, we will going to do this derivation. We are going to derive the formula, and then we are going to solve the numericals based on the cells, and then in the coming 2-3 lectures more, we are going to conclude our chapter. Okay, So till then, take care, goodbye, and please like it, share it, subscribe it. Have a nice day. Thank you.